Hello, my name is Gene. I'm an artist and software engineer from San Francisco. I'm going to tell you today about a project I've been working on for a while called Epimorphism. So it's a little complicated and a bit difficult to describe with words, so I'm just going to put on a demo of it for a couple of minutes and show you guys. All right, well, maybe you guys kind of get the idea. It's a little difficult to see in this light, though. So let me get back to the presentation. So yeah, what was that? That was a real-time random walk through the state space of a parameterized video feedback simulation. Yeah, so it was computed in parallel in real time via WebGL and pixel shaders. There was one thread per pixel. Yep, this was running on my MacBook Air, 3 years old. It's written in the language PureScript, which is very similar to Haskell and compiles down to JavaScript. So that was running in my web browser. I've been working on the software for almost 15 years in some form. The past 10 years, it's been a pure software project. It's gone through a series of modifications and iterations. Just recently, I ported it from Python and OpenCL to PureScript and GLSL. So yeah, this presentation will have maybe two parts. At first, I'll talk about video feedback and like the actual algorithm behind the software. After that, I'll get into PureScript and functional programming and all that stuff. So yeah, video feedback. I'm sure most of you are at least somewhat familiar with the concept, like Hall-Mirrors effect, things like that. If you get two mirrors back and forth or next to each other, like you kind of see a picture of the mirror in the mirror. In general, though, it's a recursive video animation generation technique, where the previous frame is blended with some kind of external information to create the next frame. And it doesn't necessarily need to be like a discrete frame-by-frame kind of system, like an analog system with mirrors. Definitely is a similar kind of effect. The basic idea, at least in the modern form, is that you hook a camera up to a display and you point the camera at the display. The camera output is its input. My software digitizes this process with a virtual frame buffer and recursive loop. So yeah, I actually have a little webcam set up right here. I'm sure you're all familiar with the concept, but I just wanted to kind of like demonstrate it. It's kind of a crappy webcam, and you can kind of see like it's not really in focus. It's kind of difficult to actually point it at the screen, but I don't know. It's like fractionally neat. I can entertain myself for a good like 3 or 4 minutes doing this. Yeah, like so I mean it has some kind of promise, but I don't know, it's kind of limited. In order to get information in there, you have to like wave your hand in front of it or something, like you can kind of see like it keeps, like the colors get messed up on each iteration. I think the camera is trying to like auto adjust the brightness or something. But yeah, I don't know, it's kind of interesting. But yeah, like the basic idea is that my software digitizes this entire process. And in order to explain how that works, I'm going to start off creating like a basic mathematical model of what was happening. So this is a screenshot of what was happening, and basically I want to try to like elaborate or elucidate what it takes to relate the input frame of a camera to the output. So we have two basic like data objects. In red is a buffer parameterized by space and time, which is what the camera is pointing at, and in lavender is what the camera is outputting. And we want to basically specify what the relationship between these two things is. The basic idea is that the output of the camera at the next frame is some transformation of the input at the current frame. Yeah, so in order to get at what this is, we're going to look at a specific point. Just take that point right there in the camera's like output, and that point over there is where it came from. There's basically, in this circumstance, two major kind of things that are happening to go from one point to the next. The first one is that this coordinate is some kind of spatial transformation of the input coordinate. So I don't want to get too much into the details of what is actually happening here in terms of like the coordinate transformation. I mostly just want to note that there is one, but in this circumstance there's like a mirroring effect. It's composed with like a zoom, composed with a perspective transformation based on the fact the camera wasn't actually like pointed directly at the screen. But in general, there is some kind of like mathematical relationship between the coordinates of the two buffers, and yeah, we just want to note that. The second thing that's happening is that there's some kind of color relationship between the 2 points. We see the original point was some very bright green, and the secondary point is a little muted or desaturated or saturated, whichever one it is. And that's an artifact of the fact that the camera can't quite pick up the colors correctly and the screen can't display them correctly. So it's just basically like some artifact which modulates the colors upon each iteration. It gets composed with itself. You can kind of see towards the middle of that image that like the white is sort of taking over and like the reds are kind of fading. It's just like losing a whole bunch of information basically. The last part of this, I basically want to explain how this input picture right there is related to the current frame. And it's basically composed of this bit of image right, or this image right here, which is the actual output of the camera, and this external information, which is in these red dotted lines. And the best way I've come across to explain the relationship between these two is that they have been blended via some alpha mask. This is a little more general than what's actually happening here, but it can also support things like waving your hand in front of the camera and transparent objects, which is kind of a useful like artistic effect. So yeah, that's basically gives us a not particularly sophisticated, but like good enough mathematical model of what's happening. It basically relates the color values of one frame with what was happening in the previous frame. We have this coloring transformation, which is an artifact of the screen color combination. We have the spatial transformation, which with a camera is a perspective transformation composed with a zoom and some panning stuff. Those kind of things. And we have this little external buffer here, which is the screen. And if you would have waved your hand in front of it, it would have been your hand, or like lights or whatever else you can put in there. And we have this like alpha mask right here, which combines the previous frame with the external information. So what's next? Yeah, and this definitely helps us understand what was going on with my software. So yeah, in my software, the feedback process is digitized. A virtual frame buffer is maintained on the GPU. And each virtual pixel implements the feedback transformation that we just kind of derived, or some particular parameterization of it where the coloring transformation and the spatial transformation take on individual values in this library that I maintain. So in my software, there's basically libraries for all 4 of these components here, the 3 we discussed, and a post-processing layer. And these components are continually blending with each other and morphing around and stuff like that. Yeah, my software maintains a data structure that's a tree, which basically, it ends up being something like an abstract syntax tree for the pixel shader, where these components we have up here, like the color transformation and the spatial transformation, are each composed of various modules that can be switched out. And the modules basically determine what code is actually executed on the graphics hardware. Yeah, and the pure script code is responsible for compiling this tree structure into various parameterizations of the transfer function. So yeah, each of these parameterizations are parameterized by numerical components, and I have the numerical components basically just like oscillating around and moving on various paths. They're complex numbers that are moving on polar curves and things of that sort. That's happening, and the tree structure itself is also like changing over time. So basically, like leaves of it are switched out with other trees, and it's just continuously morphing into other variations. So I'm going to actually show you now a demo of the development console of the software to actually see, or just demonstrate a little bit more clearly, like what's actually happening. Anybody with internet access could actually like follow along with this. My website, epimorphism.com/forum1. But anyways, we see right here basically something which is designed to kind of like mimic a screen. So yeah, that's basically a feedback system where there's nothing happening. The camera is pointed exactly at the screen, and this little red thing is supposed to be the edge of the screen. On the right, we see a little console which basically describes the data in the data structure that gets rendered into the pixel shader. We can see the components we discussed. The seed right there is what I call external information. Right now, it's just a basic frame. The spatial transformation is a basic affine transformation where nothing is happening currently. And the coloring transformation is just the identity. So what I'm going to do now is just zoom the camera out a little bit, and we see basically the fairly stereotypical feedback effect. Nothing interesting is happening, but we can already see that this is a significantly more like high fidelity, mathematically high fidelity version of what was happening. We can zoom out a little bit farther. There's also this reduction component down there, which I'll just mention real quick. Are
you bounding the number of feedback
no.
in your recursion?
Not at all. It's maybe I didn't explain this very well. So this is a live feedback system. What's being drawn on the outer frame is being drawn every single frame. What is slightly on the interior frame is the previous frame's results. So it's just constantly like taking the existing frame buffer and doing something to it and then redrawing that. So this is happening live, and there's no need to actually like bound anything. Yeah. So yeah, this reduction thing right here, the spatial transformation, it's looking for, that tells it where to look in the previous frame to get its current information. And because the previous frame is like a fixed rectangle in space, it doesn't have infinite memory, we need to map these points back into there. So I do basically like a stereotypical mirrored repeat kind of thing. You can kind of see going right there when you zoom out really far, the things outside of the square like look back into the square for information. It's not super important. But you can also do things like rotate it, and it already starts looking kind of interesting.
How are you interacting with it?
I have some keys on my keyboard that are mapped to some of the complex numbers which represent the parameters in the affine transformation. A and Z if anybody's actually paying attention. Yep, so the first thing I'm going to do right here, you can pause it, and it actually will give you drop-down menus to change all of the components. The first thing I'm going to do right here, not because it's interesting, just because it's easier to see, is put a coloring transformation in. This one right here just rotates, it does like a RGB channel permutation, switches red and blue. So on each cycle, it's just changing the color. And yeah, what I'm going to put it at right now is a hue rotation. So on each cycle of the animation, it's going to rotate the hue by a couple of degrees, and that's what's happening there. The next thing I'm going to do is to change the seed, which is the external information that's blended in here. Right now it's just a frame, but there are many variations of this. In particular, what I have For the seed, it's kind of a parameterized library where I specify basically the shape of the information that's put in there and how it's colored, which can be a texture from a library of textures or a gradient, and the alpha channel, or some opacity mask. So right here I have one which is an image. Yeah, looks kind of cool. So we see that the seed is also parameterized. It has its own transformation that determines its shape, another bit right here which determines more of its shape, some transformation of the shape, and an alpha layer. So what's happening when the software is running earlier is that all these components were switching in and out, like blending continuously with each other. Like a lot of these numerical parameters you see here are changing as well. You can click on this alpha value right here. Hopefully this works. That was not what I wanted to do. Here we go. And now it's actually got like a transparency kind of effect going on. Yeah, anyways, there's a bunch more seeds here. There's a big collection of them I stuck in here. And you can go back to here and rotate the thing. It looks kind of cool. So yeah, another thing, one of the more relevant things is in this seed library here, I have the ability to have more than one of these parameterized structures. So this thing right here is an object that has 3 different layers. So it basically takes this little seed structure that I have and puts it as 3 leaves on another like meta seed. And that's what's being rendered right here. So, okay. Looks like that. Little ugly, but not too bad. I think it looks a little cooler when you zoom in.
So now the seed is not just the outer plane, it's also going in.
Yeah, so like this, the little seed library I have right here is general. It's just like a way of procedurally generating images that tend to look good when it's sucked through this feedback system. So right now it's like, it's composed of 3 layers. One is kind of the outer frame, another is this square that's in the middle, and another is this like circular thing. But the circular thing is also put through some like spatial deformation. I'm gonna move this thing this way a little bit. You can kind of see the feedback system in effect. Anyways, so the next thing I'm gonna show you is, so with the camera, you're pretty limited in the number of the variety of spatial transformations that you can do. You have zooms, pans, perspective transformations, things of that nature. But with this system, I basically taken the 2D coordinates and interpreted them as a complex number. You very easily get to affine transformations and perspective transformations with that. But I basically have the ability to stick in any arbitrary complex transformation. Well, maybe not any arbitrary one, but basically all the elementary functions in arbitrary sequences. So this is a complex cosine.
Did you say you two-dimensional vector?
Two-dimensional vector. Sorry if I said 3.
No.
Here's a hyperbolic cosine. It looks pretty similar. I think it's just a rotated version of the other. Here's some random polynomial. Yeah, it's a fairly similar kind of algorithm. Like kaleidoscopes are based on, well, actually, a lot of that is due to this, the mirrored repeat thing I was mentioning earlier, where if it looks for information outside of its original square, it does some kind of like tiled repeat, and I think that's actually sort of similar in some cases to what happens in kaleidoscopes. Yep, so I have these kind of things right there. I also have the ability to animate these components, so let me put this on some animated path. I wonder if you can actually see it. No, nothing obvious is happening. Let me animate this. So yeah, this is moving some complex numbers around in the spatial transformation on some arbitrary path in complex space. So yeah, this is starting to sort of resemble what was happening earlier. You just basically add up all of these various transformations and abilities to do little artistic tricks and modulations and so forth, and you get the result from earlier. There's also a post-processing layer that was added to this, and basically in this circumstance does something like a hue limiting. Shouldn't be significantly obvious, but it does stop things from getting too gaudy if there's too many colors going on. On top of this, so basically like what I've constructed here is this kind of elaborate system that turns these tree data structures into pixel shaders, and it gives you the ability to switch out components of these trees and like modulate parameters. And there's really not too much of a reason to limit it to this feedback kind of structure. So within my system, I've implemented a really simple Julia set kind of construct where some of the parameters are like moving around on paths. This is using the exact same code base, like the exact same tree structure right here. You can actually go in here and change the actual polynomial that's being iterated. I don't know if this is actually going to look good, but yeah. So this is instead of like z squared plus constant, this is z cubed plus a constant. I've also got this thing going on right here, which is kind of hard to describe. It does like it's an interference pattern of like cosine waves. There's just a bunch of like wave fronts going on in the plane that are kind of interfering with each other, and you can just take some of the code from the feedback system and just stick it in here. So this is putting a spatial transformation on the entire thing and modulating it the exact same way that it was happening in the other software. So you can definitely reuse components from the other software or the other application with this thing.
Do you consider controlling these parameters in a continuous way with a continuous interface, like a joystick or something like
Yeah, previous versions of the software have had the ability to control it via like MIDI interfaces, OSC signals, things like that. I've never hooked a joystick up to it, but I don't know, there's just a sequence of like numerical parameters, like both 1- and 2-dimensional, and like they can arbitrarily be mapped to inputs and things like that. Yeah, absolutely. Other versions of the application had like a webcam input where you could actually splice webcam information into there, so it would be interesting in that way too. But anyways.
The relationship between pros and consequences would be a bit weird.
Yeah, that's absolutely true. So yeah, so that's basically an overview of how my software works and the algorithm behind it. So how much time do I have left? Does anybody know? It doesn't really matter. I have some more stuff in my presentation, but I can go straight to questions right now. That's definitely fine.
You are making an online demo tonight.
Yeah. Yes. Yeah, I'm doing a performance at the concert. There's a mildly audio responsive version of the software which should be hooked up if we can get the adapter situation resolved. But yes, theoretically it'll be on display at the concert tonight.
I happen to notice some slight stutter in the feedback mode which I can see in other modes. So what would you attribute?
Yeah, so when the tree changes, actual like the tree structure changes, it recompiles a pixel shader, and I haven't optimized that yet. So that was what that is. It's actually better than it was, but I wasn't able to completely remove it.
When does the screensaver version of this come out?
Well, it's already online. You can just go to my website and it'll do exactly that. And if you restart the application, it'll do something entirely different. If you keep it going, it'll be completely different as well, but it's already completely accessible. I mean, the thing runs on iPads, and I even got it running on my cell phone. So. I don't know. It shouldn't be too hard.
I think X screensaver just needs any programmable right on the screen. So you just write a little bit of glue and well, a bit.
So you just gave me a perfect fit for my questions there. And when I restart it, we'll do something completely different. So let's assume
say I use your program and make some awesome images as a background on some show, and later people tell me, oh, this was so cool. How did you do it? I have no idea. I clicked some parameters, and is there a way to record what I was doing? Can I, this also goes for brainstorming, you know, so can I somehow record the changes I made live so that I can later reproduce and analyze in my performance?
So right now you can create screenshots and it'll do like a parameter dump that'll tell you exactly what is defined in that particular image. There's no way to do that over a span of time, although previous versions of applications could do that as well.
Oh, but you could. Well,
you can get a parameter dump that you can then re-import and get the exact same image back.
But do you have a textual representation? So you don't just have these parameters, right? There is a script behind it. Is it possible to edit that? Is it?
The script is entirely random, and a particular image isn't very much defined based on how you got there. It's almost entirely defined by the current parameters. There's a little, like in some circumstances it gets kind of chaotic, and the previous frame actually does really like define what it is, but mostly if you just get a parameter dump at the current state, you can reproduce it pretty arbitrarily.
So there's usually a fixed point.
Say that again?
There's usually a fixed point.
Yes, it's normally a fixed point.
For your question about mid-air, yes, you can do it.
Why did you move from Python and OpenGL to PureScript? Why PureScript? Or did you just want to go into the web? Or
well, yeah, that was actually, I have a couple more frames. I got a couple more slides in my presentation that went into that. But yeah, basically it was twofold. One, yes, I wanted it on the web, but there's a lot of ways to do that. Two, I wanted to use functional programming. This is my first like major project doing something with functional programming. I have some experience with some classes in Scheme in college. Yeah, the software's been in development for a long time. The Python version got a little flaky. It's entirely my own fault. But the development model I had for that was I would work on it like 3 months out of the year, like getting ready for something, like a show or some kind of festival or something like that. And I would basically pile on lots of hacks, and it got kind of messy, and it had some architectural issues that I didn't really have the energy to fix. So I thought that functional programming could possibly like help me resolve some of these problems. I basically wanted to pay an upfront cost to have something that was more stable in the long term. I wanted to spend less time debugging things, and yeah, basically just have a more stable, more modular application where like things, once they were done, they were like fairly done. And it was a bit of a hassle to do this, to be honest, but I do think it was worth it mostly, and I am assuming that in the long term it'll pay for itself in terms of development time.
What do you think will be a starting cost of that?
In general?
Oh, yeah. Well, does it relate to that kind of feedback loop, or maybe not? I'm not sure. It's a very general question.
I'm not sure. Like, I mean, I enjoy that they found all of the planar symmetry groups in Islamic art, but I don't think it like relates too much to what I'm doing. Although I do have a couple of like Islamic tiles that get spliced in there every once in a while.